All right, so we're going to pick up here in part 2 of the Chapter 5 review. We're going to be reviewing the inequality relationships in triangles and all the different properties of triangles that we went over. So starting with inequality relationships in one triangle. So to simplify this, we have our theorems here, but to simplify this, inside of a single triangle, we can kind of rank the sides and angles based on each other. So what we're saying in these problems basically are, if this is the biggest angle in the triangle, that means the side across from it is the biggest side. If this angle is the smallest angle in the triangle, then this is the smallest side. If it's the middle angle, it's the middle side. Kind of that simple. And then we can kind of go the other way around. So if this side here is the biggest side, then that means that this angle is the biggest angle. If this side is the shortest side, that means this is the smallest angle. And same for middle. Pretty simple. It only works inside of a single triangle, though. If you want to compare two triangles to each other, we need to talk about the hinge theorem, which is in our next section. All right, so let's go ahead and do this. Oh, yeah, sorry. And also the triangle inequality theorem. Triangle inequality theorem states that sum of any two sides has to be greater than the third. Even more simply than that, the two smallest sides added together, so two smallest sides, has to be greater than the biggest side. As long as this holds, it'll work. And then the other ones will work also. So let's go ahead and look at this. So for problems like this, it's going to be important for us to sketch a picture just so that we know which sides and which angles are sort of across from each other. Doesn't matter what the triangle looks like. I don't need it to be accurate to size. I just need it to be accurate in terms of naming and relationship about where the sides are in relation to the angles. So here we have triangle UVW. Measure of angle U is 42 degrees. Measure of angle V is 99 degrees, which leaves 39 degrees for this one. I had to figure that one out. Triangle sum, they all add up to 180. Write the sides in order from shortest to longest. Okay, so we want to know what is the shortest side. That will be the first one that we list. Our shortest side is going to be across from the smallest angle. So our smallest angle is across from the shortest side, which is UV. Now our longest side, so the longest, is going to be across from the greatest angle. So the greatest angle here is V, 99 degrees. That is across from UW. So UW is the longest side, which leaves our other side here, VW, in the middle. And it's across from the middle angle measurement. So that is an order here. I could just list them like that, or I could use inequality symbols for this. UV is the shortest, so it's less than VW, which is less than the longest side, UW. So I can use the inequality symbols to convey that this is the smallest up to the biggest as well. All right, and the next example, we'll kind of do it the other direction here. So now we know the side lengths, and we're going to be comparing the angles. So here is a generic triangle, and we'll name it STU. TU is 11, US is 17, ST is 18. Okay, so we want to determine which of these three statements are true. And so we're going to compare it based on the sides. So let's see. Measure of angle U is less than the measure of angle S. So we're comparing these two angles here. U is across from 18, and S is across from 11. The bigger side is across from the bigger angle. So U is bigger than S in this case, which means that this is not true. All right, let's go ahead and look at the second one. Measure of angle T and the measure of angle S. Okay, T is across from 17, which is bigger than 11. So T is bigger than S, And that's not what this says. This says that t is smaller than s, so this is also not true. So this one is the one that needs to be true. Let's just make sure of that and examine it. So the measure of angle S is less than the measure of angle U. Okay, so it's the exact opposite of this one, which we know is true. So U is bigger. It's across from the bigger side. So U is, in fact, bigger than S. So that does work out. And a problem like this, we may want to sort of explain that thinking. So the things that I was saying, that angle U is across from the larger side, therefore it is bigger than angle S, is something that we would want to say. All right, the next couple problems are dealing with the triangle inequality theorem. So we're going to see if we can make a triangle using these side lengths. So can we make a triangle with side lengths of 2, 4, and 6? So the triangle inequality theorem would say the sum of any two sides has to be greater than the third. Well, 2 plus 4 has to be greater than the third side, 6. This is not true. 6 is not greater than 6. So we cannot make a triangle with these side lengths. This is just a no. We cannot make a triangle. However, in this next one, we can. Because 11 plus 14 is, in fact, greater than 22. Because that's 25, 22. So this one is a yes. Now, I only tested the two smallest sides compared to the biggest. That's the only one we have to test in this case, but it would work for all the others. Just to test that really quick, 11 plus 22 is greater than 14, and 14 plus 22 is greater than 11, right? It works no matter how we arrange it. Any two sides were greater than the third. All right, and now our last example here was triangle inequality theorem. We have a triangle with two known sides of 16 and 23 centimeters. So 16 centimeters, 23 centimeters. And we want to know what are a range of possible values for our third side. What's the smallest it could be? What's the biggest it could be? Well, there's two cases that we need to examine. What's the smallest that it could be, and what's the biggest that it could be? So the smallest, let's just assume that it is the smallest side. That means that if I add it with 16, the other small side has to be greater than our third side, 23. Two smallest sides greater than the biggest. Let's go ahead and solve this one real quick. So this tells me that the third side has to be greater than 7 centimeters. Okay, so that's our first case, it being the smallest side. What about if it's the biggest side of the triangle? This will be our second case. So let's say if this is the biggest, that means that these now are the smallest. So 16 plus 23 has to be greater than the biggest side, which is now x. Add those together, I get 39 is greater than x centimeters. So these two solutions here and here give me a lower bound and an upper bound for the length of my third side. It has to be greater than 7 centimeters, and it has to be smaller than 39 centimeters. And we generally write our solution here as a compound inequality like this, so that our third side is between 7 and 39. And we're not including 39 and we're not including 7 as part of our solution. All right, and then we have chapter 5.6, which deals with inequalities in two triangles. So we have the hinge theorem and the converse of the hinge theorem, which basically says that if in two triangles we have two sets of congruent angles and the angles between them are not equal, then the sides between them are also not going to be equal. And the bigger side is going to be across from the bigger angle. The bigger angle is going to be across from the bigger side. Smaller angle is across from the smaller side is across from the smaller angle. That kind of covers both the hinge theorem and its converse. Essentially, the visual that I used when we went through this lesson was an alligator mouth. If the alligator mouth opens just a little bit, small angle, it creates a small side. Whereas if it opens at a bigger angle, it creates a bigger side. And obviously the bigger the angle, the bigger that side that gets created sort of between there. All right, let's go ahead and actually do a problem with this. So when you're doing hinge theorem problems, you really want to, well, one, the way you know you're dealing with a hinge theorem problem is you have two different triangles. So in this case, we have two triangles. I know I'm using the hinge theorem. The first thing you want to do here is identify your hinge. So your two congruent side pairs. So I have one pair right here. These are both 8, so they are congruent. And then I have this shared side right here, which is obviously congruent to itself. So we have our hinge on the left side with a 95-degree angle, and our hinge on the right side with a 135-degree angle. And the larger angle, so I know the angle, I can compare the sides across from the larger side. So this side is bigger than this side. And that is the inequality that I can write. With the hinge theorem problems, I'm either going to know the angles, and I'll use those to compare the sides, or I'll know the sides, and I'll use that to compare the angles. So here we have that 3x minus 2 is greater than 10, because the angle across from it is greater than the angle across from the 10. And there we go. We get to go ahead and solve for x. We get 3x is greater than 12, and then divide by 3. We get x is greater than 4. So this is a lower bound for our problem. And in this case, I don't think we have enough information to solve for an upper bound. So that is our solution. X has to be greater than 4. Because if x was 4, we'd have 3 times 4 minus 2. That's 12 minus 2. We would get 10 for this side. And we know they're not equal because this angle is bigger. So it has to be bigger than that to make a side that's bigger than 10. All right. Here's another application of our hinge theorem. Again, first step is knowing that I'm using hinge theorem because we have two triangles and we are solving for a range of values. So we're going to be solving for an inequality. We have a shared side here in the middle. And then we have these two congruent sides here. So we have a hinge on top and a hinge on bottom. And in this case, we're kind of going the other direction here. Instead of knowing the angles and comparing the sides, we know the sides and we can compare the angles. So this third side, 25, is bigger than this side. So that means that 45 is going to be bigger than 6z, 6z minus 3. So 45 is going to be greater than, even that 45, 6z minus 3. So this lets me solve for z now. I'll add 3 and get 6z is less than 48. Divide by 6. I get that z is less than 8. Yeah, 8. Now, this is one where this is an upper bound. 8 is the highest it could be. It has to be smaller than that. I could set a lower bound here because I do know that this angle, while being smaller than 45, does actually have to exist. So it would have to also be greater than 0, right? An angle of 0 or less actually wouldn't exist. So I do know the angle has to be greater than 0. So I could solve another inequality here to set a lower bound for it, but I'm not going to do it in this case. I'm just going to be satisfied with this solution. All right, and then one more here. We're going to explain the relationship between these two angles. So between PRQ, which is right here, sorry, and SRP. Okay, so that's this angle here. And again, this is going to be a hinge theorem problem because we're dealing with two different triangles. And we're going to be comparing the angles based on the sides that are across from them. So let's identify our hinges. We have a 7 and a 7. This is one of these situations where really don't trust the relative sizes on our pictures. Trust the labeling. So these are both 7, even though they don't look like it. And then here is a shared side in the middle. I did not draw that very well. Let me do that again. Shared side in the middle, right here, RP. So these are our hinges. And we can compare the angles based on the sides that are across from them. So the two sides that are across are 9 and 5. So the bigger side is across from the bigger angle. So we can say that the measure of angle SRP, that's this one, is going to be greater than the measure of angle PRQ was the other name there. Because, I'm going to go ahead and go to the typing, because the side that is across from angle SRP is greater than the side that is across from angle PRQ. Therefore, by the hinge theorem, rather converse of the hinge theorem, we know that relationship to be true. All right, not the most beautiful explanation, but point being here, guys, just that I want you to write it out in full sentences, talk about how you applied the hinge theorem so that you compared the sides that were across from the angles, the bigger side was across from the bigger angle. And I even cited the particular theorem that I was using, which isn't strictly necessary, but always a good thing to do if you can. All right. And then our last section was all about Pythagorean theorem and special right triangles. For the test, the only thing that I'm really going to have on there are special right triangles. So we have our 45, 45, 90. In the 45, 45, 90, it's also isosceles. So these legs are the same. The legs are equal. And then the hypotenuse is equal to the leg times root 2. In the 30, 60, 90, we have our short leg. I'm going to abbreviate that SL. So our short leg is the one across from the 30. The hypotenuse is 2 times the short leg. And the other leg here, the long leg, is equal to short leg times root 3. So basically, a lot of these problems are going to involve finding either the short leg or the leg length and then kind of using it to figure everything else out. So figuring out the x for our particular triangle. All right, so here we have some 45, 45, 90s, and we know in this one, we know the leg. So this is the leg, and our hypotenuse is equal to the leg times root 2. So leg times root 2. So that's just 8 root 2. Very easy problem for that one. Very easy. Now this one, a little bit more complicated. This one is our x root 2 side, our leg times root 2 side. So we actually have to do a little solving for that. So I get that 18 equals x root 2. And I need to divide by the square root of 2, which is always a bit of an adventure. So 18 divided by square root 2 equals x. Here, this is a problem that needs to be what's called rationalized. We never want to have a radical number in the denominator. So you have to multiply the top and the bottom of this fraction by this radical. So you multiply by the square root of 2 on the top and the bottom of this fraction. So again, I'm multiplying by the square root of 2. Now here on the bottom, I'm just going to get 2. And on the top, I'm going to get 18 times the square root of 2. Those don't actually go together. There are a little simplifying that can take place. 18 and 2 are both divisible by 2. So if I divide those, I get 9 and 1. So this becomes 9 square root 2 for x. So these sides, my legs, are equal to the x. They are both 9 square root 2. But this type of problem is like way, 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 way more difficult than this type. So for a 45, 45, 90, it's a lot harder if you're given the hypotenuse, particularly if it's a whole number like this compared to if you're given the legs. All right, let's go ahead and clear this and do a couple examples of the 30, 60, 90 as well. All right, so first one, we are given the short leg. This is the short leg. It's across from the 30. So this is our x side. This is our 2x. The hypotenuse is 2x, and this is our x root 3. Okay, so in this case, our x is 1/2. So this side is 2 times that. 2 times a half is just 1. So this side is 1. And this side is 1/2 times the square root of 3. Or the way that we write that is square root of 3 over 2. So here are our solving for these particular sides. I'm kind of ignoring the labels that they did. This is a little confusing. When we have an x here and we kind of use x to define our triangle, I am kind of ignoring those. I'm solving for them, but I'm kind of ignoring what they're labeled for now. I'll go through this next one a little slower. So here, this is the hypotenuse. This is our 2x side. Our short leg is the x side, and this is our x root 3 side. We know this one. We can use it to set up a quick little equation for ourselves. 2x equals 6 divided by 2, x equals 3. So our short leg side is 3, and this side is 3 times the square root of 3. So those are our 3 sides of this particular triangle. It's all about solve for x, right? We got to find out what x is, and x is the short leg. And if you can figure out the short leg, you can kind of figure out what all the other sides are. All right, that's all, guys. Good luck on the test. I'll see you guys later.